index numbers are very useful for making comparisons, especially over time. Sociologists are interested in looking at index numbers to see what's happening with population changes. Businesses look at index numbers to look at share prices. Psychologists use index numbers to consider intelligence levels of populations. The measure usually works by establishing a base which is given the number 100. Variations are then measured from that. So the average intelligence is supposed to give a number of 100. If you have an IQ of 130, you're supposed to be 30% more intelligent than the average. Perhaps the most common use of index numbers is in measuring the extent of price increases in the goods and services that we buy. One measure of that is the gross domestic product. Now, GDP tends to rise for two reasons. One, we produce more goods and services. Two, the prices of these things is going up. Now, index numbers are very useful in separating out these two effects. But to do that, we first need to be clear on what we mean by GDP, and we can do that by looking at a particular European economy. How much output does a society produce in the course of a year? It sounds a remarkably simple question. All you do is take the output that everybody produces, multiply it by the price it sells for, and you've got the output. It's a simple way of doing it, and it's wrong. And the reason that it's wrong is that you are double counting. You're counting some outputs more than once. You see, some of the output which is made isn't sold to consumers at all. It's made and sold to other producers. So the farmer grows his wheat and he doesn't sell it to consumers. He sells it to millers who take this wheat and turn it into flour. And then the flour is sold on to the bread manufacturer who turns it into bread. So if we took the output of the farmer's wheat, the miller's flour, and the bread producer's bread, we'd be hopelessly overstating the total amount of output that's produced. We'd be double counting some of the output. So the way over the problem is this. Way one, we just count the output that is sold to consumers. So for this particular industry, ignore the contribution of the farmer producing the wheat, ignore the contribution of the flour producer, and simply say how many loaves of bread were produced and what's the price. We only count the final output. Possibility number two is to say, let's look at the contribution made by each producer by asking what's its value added, what's the difference between the value of the output they produce and the value of the inputs bought from some other industry. So we take the farmer's wheat, he sells the wheat for €100 to this miller. The miller takes €100 worth of grain, turns it into €200 worth of flour. What's the miller done? He's added €100 worth of value to the wheat. That is his value added. If we do the same thing now with the bread producer, value the output of the bread, minus inputs from the miller, we've got the value added at that stage in the production process. If we add up the values added of each stage in the process, we've got the total value of output to society, which is exactly the same as the value of the output that we found when we ignored intermediate output and went straight to the final producer, the bread manufacturer. So we've got these two ways of doing it. All the national income accounts that you'll see use that second way. And the reason for using the second way is that if you looked at national income accounts in the first way, you'd never know that there were any farmers. You'd never know that there were any millers. But doing it via value added and you see the contributions made of all producers in all industries within the country. When GDP increases, is it because we're producing more or because the price level is rising? We need to be able to separate out these two effects, so we need to be able to measure inflation. And a good way to measure inflation is to use index numbers. Since an economy is so complex and has so many prices, and all these prices are changing at different rates, let's come back to my island economy and see what's happening with our very simple economy. In an earlier film, we saw how our island economy suffered from inflation. Now what we want to do is to try to measure that inflation using index numbers. Now our island produces a number of different commodities, and their prices have tended to rise, but not all by the same extent. So how can we measure the rate of inflation on our island economy? It's too simple an economy to have specialisation. There's no intermediate output. We just have four of us, each producing and exchanging our products. But last year our prices were different from this year. Furthermore, although prices have generally risen, they haven't all changed by the same amount. So how much inflation is there? Could we take a simple mean average of all the price changes? We could, but it wouldn't be very good because some items are more important to us than others. And we know that because we spend more on some items than we spend on others. The table shows the prices of each commodity sold on our island in 3 different years, and also the quantities sold. The changes in quantities will reflect partly changes in preference and partly changes in the price of the goods themselves. With year 2 as the base year, we'll construct a price index measuring the change in the price level on our island between years 2 and 3. Remember, we can't work out the percentage change for each price and then take a mean average of the changes, because this would ignore the fact that some prices are more important than others. We get an idea of the relative importance of the prices to our economy by looking at the quantities of the goods purchased, so we can weight the changes using the formula below. The index I equals sigma Pn Q0 over sigma P0 Q0 times 100, where I is our price index, sigma means the sum of, Pn represents each of the given year prices, in our case year 3, and P0 represents each of the base year prices, in our case year 2. Q0 represents each of the base year quantities that we'll use as weights. So substituting now into our formula, we have the following. We're using the year 3 prices of each commodity in turn, multiplying each one by the appropriate base year weights, the year 2 quantities. That's the top line. So I equals 3 times 3 plus 2 times 6 plus 2 times 3 plus 4 times 3. And now we divide by sigma P0 Q0. We take the year 2 price of each commodity and multiply each in turn by the base year weights, the year 2 quantities, and add these to give us the bottom line. So the bottom line is 2 times 3 plus 1 times 6 plus 2 times 3 plus 4 times 3. Now we multiply the result by 100. And this gives us that I equals 9 plus 12 plus 6 plus 12
divided by 6 plus 6 plus 6 plus 12, and we multiply by 100, which equals 130. So the index of prices in year 3 is 130, and we've had an inflation rate in our island economy of 30% between years 2 and 3, according to this inflation measure.
We've just produced a L'Espears index after the name of the guy who thought of it, but we've got a problem. The problem is this, that when prices are rising, and some are rising faster than others, consumers respond to that by changing their expenditure patterns, buying more of the goods which are falling relatively in price, and less of the goods which are rising in price relatively. So there's a case for saying that we ought to change our weighting system to allow for the fact that consumers' expenditure patterns have changed. Let's do that for our island economy.
Referring back to our table of prices, we can now calculate the inflation rate in an alternative way. Again, with year 2 as the base year, we'll construct a price index measuring the change in the price level on our island between years 2 and 3. This time we use the Pash index. As before, we can get an idea of the relative importance of the prices to our economy by looking at the quantities of the goods purchased. But this time we use the current weights, the weights that pick up the changes in quantities consumed over the period. We can weight the changes differently this time using the formula I is sigma PNQN over sigma P0QN times 100, where I is our price index. Sigma again, of course, means the sum of. PN represents each of the given year prices. P0 represents each of the base year prices, and QN represents the current year quantities that we'll use as weights. So substituting into our formula, this time we perform the same operation as before, except that each of our year 3 prices is multiplied by its current year weight, the year 3 quantity, the top line. So I is 3 times 6, plus 2 times 4, plus 2 times 7, plus 4 times 3. And on the lower line, we multiply each year 2 price by the appropriate year 3 quantity weight. 2 times 6, plus 1 times 4, plus 2 times 7, plus 4 times 3. And then again we multiply by 100, so that I is 18 plus 8 plus 14 plus 12, which we add up and divide by 12 plus 4 plus 14 plus 12. Multiplying the result by 100 gives us 123.81. So the index of prices in year 3 is, according to this measure, 123.81, and we've had an inflation rate in our island economy of 23.81. This measure tends to show a lower inflation rate because it allows for consumers adjusting their purchases to relative price changes. There are various sets of index numbers that measure inflation for the UK. They're all constructed in the way we've described for our island economy, but the weights used to calculate price changes will vary according to the use to which we put them. We'll mention just a few here.
The best known measures are the Retail Price Index, the RPI, sometimes called the headline rate, and the CPI, the Consumer Price Index, which is the one which is used throughout the European Union.
Over 100,000 price quotations are analysed for price changes, each carrying its own weight to reflect our expenditure patterns. So in recent years, some items have been added. These include lip gloss, hair straighteners, and small bottles of mineral water. Others have been removed. These include squash court hire and eyesight tests, which have become free in some areas for many people.
Others have stayed the same, but the size of the weights has altered. So now, for example, people tend to spend a higher proportion of their income on travel, a lower proportion of their income on food. So what's the difference between the RPI and the CPI?
There are things left out of CPI that RPI includes. RPI, for example, covers council tax and mortgage interest payments. The CPI measure does not, and that's true of some other housing costs also.
We also have a wholesale prices index. Any store will buy its goods for less than it sells in order to cover its costs and make a profit. So we can measure prices not only at the point of sale to the customer, but we can also measure prices at the point of sale to the store. One of the advantages of doing this is that it gives us an indication of price rises yet to come.
One worry about inflation is how easily it can become hyperinflation. That's where prices are rising so fast that people lose confidence in money as a medium of exchange, as a way of settling debts, as a way of selling and buying goods and services. The fastest ever known rate of inflation took place here in Hungary during the 1920s, 30s and 40s. The unit of account at that time was called the pengu. And hyperinflation was such that by the time we get to the 1940s, there were notes being printed by the government for 100 million billion pengos. One of the effects of rapid inflation means that the value of the currency internationally falls. So if we come back to this example of Hungary, in 1927, a US dollar exchanged for 5 pengus. By 1946, 1 US dollar bought 4.6 times 10 to the 29 pengus. That is to say, it bought 46 plus 28 zeros pengus. That is a serious rate of inflation. In Western Europe, we've been accustomed to seeing price indexes rising by only a few percentage points a year. But there have been exceptions to this rule, not only in Hungary, but some countries have experienced hyperinflation in their history. One such country was Germany, now a prosperous, relatively low inflation economy. But let's look at the index numbers of German inflation for the period from 1914 to 23. Note how the base doesn't have to be a year-long period, or indeed be equal to 100. Here, it's a particular month, and the base period is given a value of 1. Let's get a sense of how fast prices were rising using the index above. If the German 1923 rate were to be repeated this year, we can work out what a typical good that cost £1 in July would cost by November. The current index is Pn over P0 times 100, which is 726,000,000,000,000, the November price, over 194,000,000, the July price index, which we then multiply by 100, which gives us 374,226,804. So the good whose price was £1 in July would, if the German 1923 rate of inflation were to take place in our economy, have a price now in November of 374,226,804. £804. We focused in this film on the measurement of inflation, a subject of great importance in the social sciences. Yet it hasn't been our main purpose to help you understand inflation. Our chief purpose hasn't been to enable you to understand everything about prices, but to help you feel confident in the handling of index numbers.